Okay, so homework 3, we're looking at some absolute value equations. Now the first thing we want to do is look at the different regions for these absolute values, and we do that by checking the breaking points. So we take the inside function and see where is that equal to 0. So if we solve that, we should add x to both sides and see that x should be 2. And likewise here we can see that, well, the breaking point here, x would be equal to 1. So what we do now is we draw up a real number line of x values here, and we position them in a table. So we can see there's going to be two values here, 1 and 2. So here we've got the values of x between 1 and 2. Here we have x values bigger than 2, and here we have x values less than 1. Alright, so these are the different regions that we have, the intervals for x. So we're going to find the solution set for this absolute value equation by hand. And the way we do this is to check in this region, where x, for each region, check if the expressions are positive or negative. So let's pick something less than 1, I don't know, let's say 0. So if we say 2 minus 0, that's positive. So we'll just have 2 minus x. And 0 minus 1, well, that will be negative. So this will be equal to a negative value, which would be 1 minus x. And we'll do the similar sort of thing for each section. I encourage you to pause the video now and try this for yourself, and then we'll see how I will do it. So for this value here, let's say it's 1.5, let's say. So 2 minus 1.5, that'll be positive. So 2 minus x, I'll have to write fairly small here. And let's say 1.5 minus 1, well, that's going to be positive. So this will remain unchanged as well. Great, so now for bigger than 2, if x is bigger than 2, let's say 3, you have 2 minus 3, that's going to be negative now, so x minus 2. And then if we had 3 minus 1, well, that would be positive, so that remains unchanged, equals x minus 1. So now we just go ahead and solve these equations as we would normally. So if we subtract x from each side, we get 2 equal to 1. So that's not possible, there's no solutions there. If we add x to both sides, we'd have 2x, and add 1 to both sides, we'd have equal to 3. And then dividing by 2, x would be 3 over 2 there. So that's a possible solution. And now let's subtract x from both sides, so we get minus 2 equal to minus 1. Not possible. All right, so we should now also check. So to check these, we should substitute also the breaking points and the possible solutions into our original equation to check if they work. So let's see, if we have the absolute value of 2 minus 1, well, that's 1. Is that equal to 1 minus 1? No. Okay, so now let's try 3 over 2. If we have 2 minus 3 over 2, 2 minus 3 over 2, is that equal to 3 over 2? All right, let's try that again. That's a bit messy. Is that equal to 3 over 2, absolute value of 3 over 2 instead of x, minus 1? All right, well, this would be minus a half, because it's 4 over 2 minus 3 over 2. Is the absolute value of minus a half equal to a half? Yeah, that's true. And then finally, we should check 2. So if we have 2 minus 2, that's an easy one. That's just 0. Is the absolute value of 0 equal to 2 minus 1? No. So we have one possible solution, which was 3 over 2, and we write our solution set like this. Okay, so B looks a little bit easier in that there's only one absolute value now. So here we'll check the breaking point here. When is this equal to 0? And we should subtract 3 from both sides and divide by 2. So 3 over 2. So that is the important breaking point here. So we should have two expressions either side of minus 3 over 2 along the x values. So here, one region where x is less than minus 3 over 2, and, oh, sorry about that, let's erase that little bracket, and bigger than x, bigger than minus 3 over 2. All right, so now, let's see. If we put in substitutes and values, will this be positive or negative? So let's try, what's something less than minus 1.5? Maybe minus 5, that's definitely. So let's see, if we have minus 5 here for x, that would be minus 10 plus 3. That's definitely going to be negative. All right, so we need to change here this bit part inside the absolute value to negative. So when we do this, it will be minus 2x, minus 3, and the rest is all exactly the same. So plus x minus 1 equal to 0. Right, so now let's try something bigger than minus 3 over 2. How about positive 5? So if we put in positive 5, again that's 10 plus 3, so this time it's positive. So this does not change the expression, so it will remain as 2x plus 3. And the rest as normal. So now we have two equations that we should solve. So now we have minus 2x and x, looking at the like terms. That will give us minus x. And the rest of this will give minus 4. And if we add 4 to both sides, we have minus x equal to 4. And so x would be minus 4. And if we look at the right-hand side, now we have 3x. And if we add our numbers, just the constants, we have plus 3 minus 1 gives us 2, subtracting that. And x is going to be dividing by 3, minus 2 over 3. Right, so we should check all of these values. Check minus 4, check minus 3 over 2, check minus 2 thirds. So very quickly, let's check. If we have minus 4 for x, this is going to be the absolute value of minus 8 plus 3, which would be minus 5. And plus x, so minus 4, minus 1, is that 0? Let's see if we have, that's 5, minus 5, yes, that works. I've run out of room to do the other two, but we should see from the solutions here that minus 4 should be a solution and minus 2/3 should also be a solution, and this one should not. Okay, so let's go straight on to the last question now. Here we get back to a two absolute value equation, so we need to find the breaking points. We see x must be 3 here and 7 here. Draw up our table. We should be getting quite good at this by now. Okay, so which one's smaller? 3 is smaller than 7. All right, so now let's substitute. So let's start with the left-hand side over here. So we'll start with a value, let's say 0. 3 minus 0, that's going to make this positive. So we'll have 3 minus x. And in the second absolute value, if we substitute 0, this will be negative. So this should be plus 7 minus x equals 12. Something in the middle here, let's say 4. So if we have 3 minus 4, that's negative. So x minus 3. And let's say 4 here, this also is negative. So it would be plus 7 minus x equal 12. And something bigger than 7, let's say 10. So 3 minus 10, that's going to make negative 7, which is obviously negative. And let's write this a bit further down, give us a bit of space here. X and the 3 will be negative. And in this x minus 7 section, 10 would make this positive. So plus, and just keep it exactly the same. X minus 7 equal to 12. Now it's just equations to solve. Let's group these together here. We've got x minus x gives minus 2x. And if we group the numbers, we have 3 and 7 gives 10. If we subtract that from both sides, we would get 2. Dividing both sides by minus 2, we get x equal to minus 1 in the middle. Okay, here we have x minus x. That's nice and easy. So we have, what do we got? Minus 3 plus 7, 4 equal to 12. That's never true. Let's see, we've got x plus x is 2x. And minus 3 minus 7 gives minus 10. Add 10 to both sides, we get 22. X dividing by 2 gives 11. So we have a few values to check. We've got 3, minus 1, 7, and 11. So let's do some checking. All right, so for x equal to minus 1. So over here we have 4. The absolute value of 4 is 4. Minus 1 here gives us 8. So 4 plus 8 equals 12. Yep. So minus 1 works. For 3, let's see if we have, that would be 0 for the first absolute value. Absolute value of minus 4 would be 4 equal to 12. Nope. 7, let's see. So for 7 we would have let's see, 3 minus 7 would be minus, absolute value of minus 4 is 4, plus 0 is 12. No, that's not true either. Let's try 11, and if we have 3 minus 11, that gives minus 8, so the absolute value of that is 8, plus if we have 11 minus 7 gives us absolute value of 4, that's true, and so that value is true. So those two are the elements of our solution set. Hope you enjoyed this video.